picture the spinner there. So number 1 is, what is the probability that you land on an even number? Answer both a fraction and a percent. Well, I need to figure out my even numbers. Can someone raise their hand? What are my even numbers?
2, 4, 6, 8.
Good. 2, 4, 6, 8. Who do we? No, sorry. It is 2, 4, 6, 8. So there are 4 even numbers. Out of how many numbers in all? Well, it's a spinner out of 8, so it's 8. Yeah. Good. We always have to look. Can we reduce our fractions? Absolutely, we can. This becomes 1/2. And then it says answer both a fraction and a percent. So 1/2 we know is 50%. We need both to get full credit. Number 2, what is the theoretical probability that you spin a number bigger than 3? Answer in both fraction and percent. Is 3 bigger than 3?
No.
No. So we don't count 3. We're just going to do the numbers bigger than them. So 4, 5, 6, 7, 8, 9, 10. How many numbers do we have that are bigger than 3?
6.
Oh, sorry. It only goes up to 8. You were right. 5. Ha. I don't know why I'm counting to 10. Sorry, guys. So 4, 5, 6, 7, 8. 5. Good job. Out of how many numbers in all? 8. Can we reduce 5 eighths?
No.
No, we can't. So, what is 5 eighths as a percent? Because it says we do need to do it as both a fraction and a percent.
What?
So we need 5 eighths as a percent.
Oh my god. 62%.
I think it can go to the nearest tenth and not round.
Oh.
62.5%. Yep. 62.5%. Okay, what is the probability that we get a 5 then a 6? Well, what is the probability of a 5? 1 out of 8. What is the probability of a 6? 1 out of 8. What sign goes in between them? Multiplication. 1 times 1 is 1. 8 times 8 is 64. Does it say we need it in both a fraction and a percent? Nope, so we're good. Don't do both. Why? What could be wrong with us doing a percent as well?
You can get the percent wrong.
Yeah, what if we make a stupid mistake and round the percent wrong? Or say the wrong percent? Then I'm stuck taking off points when you didn't have to do it anyway. So just leave it if it says it. All right, the probability of not a 1. So this is everything except 1. So how many numbers are not 1?
7.
There are 7 not 1s. Out of how many numbers in all?
8.
8. Do I also have to write this in a decimal or a percent?
No.
No, so I might as well leave it. I'm good with that. Number 5. Trogdor rolled a number cube 20 times. The results are in the table. What is the experimental probability of Trogdor rolling a 1? Well, how many times did Trogdor roll a 1? Twice. Out of how many rolls in all? Yes, we could add that up, or we can just say it tells us right in there how many times he rolled it. So what should my bottom number be? 20. Can we reduce that?
Yes.
Yep, to 1/10. Do I have to write that as a decimal or a percent?
Apparently I copied
Do I have to write that as a decimal or a percent?
No.
No. I can, but again, why make life harder? All right, now it wants the theoretical probability. That means what should happen. So ignore all these. If we roll a number cube, how often should we get a 1? What is just the regular probability of getting a 1 on a normal number cube? 1 out of 6. Here's the only thing that matters to me. If you go fraction here, go fraction here. If you go percent, then they should both be percent. It's really hard for someone to compare 1/10 to 16.6 repeating percent. Like, you know what I mean? Just have them both the same so it's easy to compare. So here is the theoretical probability. Here is the experimental probability. As it's lagging behind me. There we go. Number 6. Rewrite the following question without bias. Do you hate having homework on the weekends? A lot of different ways we could do this. Often just asking people to rate is easy. Rate how you feel about having homework on the weekends, or just ask an open-ended question. How do you feel about having homework on the weekends? But get rid of the things like don't you hate or don't you like, or the words like more or less. So even something like, how do you feel about homework on the weekends? All right, flip it over. Number 7, Sally wants to start a soccer team at the junior high. To show it's a need, she wants to show the student perspective. She leaves a pile of surveys at the gym entrance for any student who wants to fill out a survey. Is this biased or unbiased? Explain your reasoning.
It is biased because she's only doing the people in the gym instead of the school. Wait, she's only doing the people in the gym, and she wants to do the entire school.
Right, but remember, anyone who enters the gym could take it. I agree it is biased. It is absolutely biased. But not necessarily, it could be because it's a convenience survey, but there's a deeper reason. It's voluntary. Who's going to take that? Probably the people who want to start the soccer team. If you don't care about the soccer team, you're not going to waste your time filling out the survey. And there's probably a good chance that no one's going to be so anti-soccer that they're going to pick up and be like, no soccer teams. No one should have fun. Like, I don't think anyone's going to do that. But chances are you're going to get like 100% of the people say, yeah, we want a soccer team, because those are the only people who are willing to take their time to do it. So it's a voluntary survey. So it only touches on the people that it affects positively. It's not a true representation of who is interested. Number 8, Davon wants to survey the students at Redline to determine how students feel about school lunch. He asked every 20th students that leaves the cafeteria about their lunch. Is the survey biased or unbiased? Remember, this is the one where I said you can actually make a case for either, and as long as you make a good case, I can deal with it. Can someone tell me why it might be biased? What would a good, legitimate reason that it is biased be?
Because it's voluntary, because he's only asking 20 people out of everybody.
You're right that it's only every 20th person, but that doesn't make it voluntary. It makes it something else.
He's only asking the people who, he's asking every 20th student, but, some of them might have packed lunch.
Good. Some of them might have packed lunch. That's called a biased population. So we're not asking necessarily the people that we want to hear from. The people who pack their lunch probably don't have anything relevant to say about the school lunch. So it's biased due to a biased population. You could convince me it's unbiased, though I think it's a weaker argument, because you could say it's a systematic survey, which is a fair survey method. Remember, systematic means that it's not random, like we have a system in place to figure it out, but the people who go by is random. Like, you're not picking and choosing who you want to ask, you're just saying every 20th person. I think biased is the better answer, but if you went unbiased on this one with a good explanation, I can live with that. Number 9. Bless you. Zay is doing a project to determine the health of the school climate of the entire Red Lion district. He sends out a survey form to random classmates. Biased or unbiased? Explain.
It is biased because he's only doing his classmates, not the entire class.
Exactly, it's biased. Because it's called a convenience survey. He wants to know about the entire Red Lion district. And if he wants to know about the entire Red Lion district, he needs to get representatives about the entire district. He doesn't have to ask every student, but his population has to represent everyone. He's just asking his classmates. Sorry, Zay, that doesn't fly. Number 10. The We All Play Together preschool took a poll of their 370 preschoolers to see what their favorite color is so they can order the right background for their class pictures. If only 200 students typically order pictures, how many gray-colored backgrounds would be a safe guess to pre-order? Well, this is using experimental probability to predict. So how many people ordered gray? It's a lot easier to see on your paper than on my overhead. 28 did. 28 people ordered. Out of how many? We don't have to add them all up. They tell us. They tell us how many people. Yeah, 370. There's two ways you can do this. Way number one is we can figure out that as a percent. So what is 28 370ths as a percent? 7.56%. Did you have to round that? Or did it just stop at the 5.6? It keeps going, right? So it comes up to a nasty percent, huh? That we have to round. The issue is when we round the percent, it's then going to kind of round our answer. So maybe we can choose a better method, and that's using a proportion. So we'll use this as the first part of our proportion, and we'll set up the second part of our proportion here. And the other number we're dealing with is 200. Well, the top is 28 gray out of 370 students. So I know my labels here are gray over students. So where does my 200 go? Is it 200 grays or 200 students in all? Students. So that's 200. What goes up top then?
X.
Yeah, an X. We don't know. We can then cross multiply, and we get 370x equals, what, 5600, 5600?
Yeah.
We'll divide both sides by 370. And read out exactly what you get. I'll probably cut you off at some point.
15.135135.
1351 ... Yes? Okay. Can a company order 15.1351 backgrounds?
No.
Think like a business. Does it make sense to order one too few or one too many? One too many. We don't want to run out. Now, we don't want to order like 28 too many, but we don't want to come out just a little short. So we should probably order 16 gray backgrounds. I know this number should round down to 15, but we're not rounding. We're using that to help us to figure out how many to order. Does that make sense? Why we're not rounding, we're bumping up. Yes? All right. Flip the page one last time. When buying a car, you can get it, oh, I should let that catch up with me. There we go. In automatic, 5-speed manual, and 6-speed manual. With or without a sunroof, and in blue, red, black, or white. Use the fundamental counting principle to determine how many combinations you can have. This is a much easier problem than it looks. How many different types of transmissions could I get?
3.
Yep, I could get 3 different types. What about my sunroof options? How many sunroof options do I have?
3.
Careful. How many? 2. 2 different types of sunroof options. What about how many colors I can order it in?
6.
Careful.
Or,
How many different colors?
4.
4. I can do blue, red, black, or white. 4. Now, I know it's called the counting principle, but what do I actually do? I'm not adding them up. I'm doing something different. I'm multiplying. Yes, you'll be able to use your calculator, but we can do this in our head because we know that 3 times 2 is
5.
6 times 4 is 24. So there are 24 different combinations. Now, the last thing is we're going to draw a tree diagram. So, we can get it in automatic. We can get it in 5-speed. And we can get it in 6-speed. I'll write it and then I'll make sure that it is zoomed out enough that you can see. Cutting it close, but I think we can make it work. There we go. All right, for automatic, now we can get sunroofs. So my two choices are with a sunroof and without a sunroof. For my 5-speed, with a sunroof, without a sunroof. Unfortunately, I think I am going to have to zoom out just a little bit because once our tree gets a little bit bigger, we won't be able to see anymore. And my 6-speed with a sunroof, without a sunroof. Last is the colors. So I can get automatic with a sunroof in 4 colors. I can't just use B, R, B, and W because 2 of them start with B. So we've got blue, red, black, white. I can get without in blue, red, black, white. I can get my 5-speed with a sunroof in blue, red, black, white, without a sunroof in blue, red, black, white. And finally, I can get the 6-speed in blue,
Mr. Shaker, how do you get colors if there's no sun?
the sunroof is not the color of the car, it's that color.
Oh.
The color of the car is blue, red, black, or white. A sunroof is typically just made of glass. Blue, red, black, white. And remember, we typically only count the far end of the tree to count our total possibilities. And hopefully, if we did it right, we will come up with our original answer of 24. That's a great check. Our final number should match what we got with our counting principle. If not, something went wrong somewhere. So I've got 1, 2, 3, 4. Then another 4 makes 8. Another 4 makes 12. I know it's so far behind me. Another 4 makes 16. 20. 24. They match. Your quiz tomorrow will look almost identical to this study guide.